Welcome to Green Slate & Company. My name is Larry Borowski, also known as Mr. Measurement, and today we're going to be discussing the proper use of the threaded plug gauge. Before you start really using a plug gauge, you really want to know what you're doing, why you're using it, what it's for, things like that. So we're going to invoke our ASME document to help us understand that. The GO gauge represents the maximum material functional limit of the product internal thread, and its purpose is to assure interchangeable assembly of maximum material mating parts. So basically, it makes the GO plug make sure that your parts are not undersized and that it will mate with the biggest size bolt. Flipping over to our NOGO end of things, the NOGO or high thread plug gauge represents the NOGO or high functional diameter limit of the product internal thread. In other words, the NOGO makes sure that the part is not oversized. We're going to refer to all these things as work plugs. That's just another name for the threaded plug gauge. And so the different kinds we have, there's a taper lock, which is, like the name says, the shank is tapered so that it goes and locks itself into a handle so that you can use it. Another kind is called a reversible, and that is reversible. You can use it from one side or the other side, doesn't matter. But this type of smaller one will fit into what's called a reversible type handle. Also reversible is sort of the bigger ones, they're reversible as well, and they fit into, they get bolted actually onto a handle. The next step before we check parts is going to be make sure that our gauges are properly calibrated. Quick tell on whether or not our gauges are calibrated is typically a calibration sticker. Minimally, it's going to have some kind of a gauge ID that identifies that particular gauge, and it's also going to have a due date, the next calibration due date. As long as the due date is in the future, you're good to go as far as using those gauges. While we choose our gauge, we also want to make sure that we have the correct one. I've already done the homework on what we're going to be checking today, and that is we're going to be checking a 1032 2B. That's what our print says, that's what our specs say. So I've got two different kinds of product. I've got just a nut, and I've got what represents a tapped hole, and a casting, a plate, some other kind of product is the tapped hole. The big thing about that is that we want to make sure our class of fit, our pitch diameters, everything matches what our prints or our specs need to say. So all that information will be marked on your handle somewhere. Before we actually apply our gauging to our product, we just want to make sure everything's clean. You can use your shop air hose, blow the holes out, whether it's product or that, blow the gauge off. Just debris is an enemy of your gauging, so it just causes premature wear. You just want to make sure that the things are clean as they're going in, and it doesn't interfere with your inspection process. The GO thread plug gauges must enter and pass through the full threaded length of the product freely. What that means is that we're going to engage our thread, and it has to freely go the entire length. So once it pops through the other side, you're done. You don't have to keep going the whole length of the plug gauge, just the length of the product. And if you have a problem with the word freely, we've discussed this in another video on ring gauges, my suggestion is to go to an alternative method where you can actually get a size, and it takes the subjectivity out of it. Flipping over to our NOGO end of things and how that works, the NOGO or high functional diameter is acceptable when the NOGO or high thread plug gauge applied to the product internal thread does not enter more than 3 complete turns. The gauge should not be forced. Similar to our language on the GO gauge with the freely, you've got this other term that says shouldn't be forced. Again, there's some subjectivity about that. We apply our NOGO to our product, and again, it stops up. I'm not going to force it. Again, a bipoint gauge or some kind of internal variable gauging that does a direct measurement will tell you if you're not sure if you're truly forcing it through or not. In order to demonstrate the NOGO rules with you, we actually prepared a plate that is, we purposely tapped oversized so that we can see what that looks like when it goes more than 3 turns. So once again, we engage our thread, and it's a good idea if you're trying to count your turns is to have a reference point. In this case, I've got this calibration sticker label, it's facing up. And so I'm just engaged. I turn it once, I turn it twice, I turn it 3 times, and it's still freely going. After the 3rd time, there's really no reason to keep going. At that point, you're just kind of wasting time. You've got a bad part. As far as the use goes, we know that the go gauge has to go freely the entire length of the product, not the length of the plug. And the no-go should not go more than 3 turns without forcing it. So once we're done using our gauges, the other thing we want to do is just we want to make sure we're caring about our gauges. We're treating them properly. One way that we want to preserve our gauges is if you have a wax dip that you can dip your ends of your plug gauge in. It creates a bumper. It also creates an oily film in there that prevents rust corrosion. And you can get fun with it with the red and the green as well. And so if you don't have the means for that, another way to do it is just to store it in cases. And that just prevents dents, stings, they fall off the table, they get damaged. So you just want to make sure when you're putting your gauges away that you do store them clean, store them protected, and store them oiled. Before we wrap things up, a couple fun facts I wanted to share with you. The go member is always long. Oops, sorry, got that backwards. See that? The go member is always longer than the no-go member. That might not be as easy to see on the little ones, but this one can definitely see the difference. What's quite interesting too, the no-go really doesn't have to be more than 3 threads long because you're not using it beyond that. Other cool thing that if your plug gauge is just sitting on the table and you're like, wow, I can't really tell which side is which, the go is always put on the side where there's either a hole or a slot. And the reason for that is that it's easy to change out. The go is going to exhibit more frequent wear than the no-go, and therefore probably going to get replaced more often than the no-go. So it gives you an easy access to just pop the member out and put a new one in. The chip groove is only really found on the go because there's no real reason to put it on the no-go. Chip groove is this groove right here. It's on that one. There's a little tiny one on the smaller ones, but once you get down to about a size number 8 or like an M4, they no longer put the chip groove in there just because it wipes out most of the function of the thread. So it becomes kind of a not necessary thing, more detrimental than helpful. Hopefully today was informative for you and you've learned something about using threaded plug gauges. And if you have any questions, feel free to reach back out to Mr. Measurement. Check out our website. You can email us. You can call us. Stay tuned for more videos on different topics. Thank you.